All right, so today we're going to dive into a legendary math problem. We're talking about a puzzle that a young genius supposedly cracked in just a few seconds, completely blowing his teacher's mind. So let's break down exactly how he did it and what his little trick teaches all of us about finding simple answers to really complex problems.
But first, a quick question for you. If I asked you to add up every single number from 1 all the way to 100, how long would that take you? I mean, it sounds like a real slog, right? You'd be there for a while, punching numbers into a calculator or scribbling on a piece of paper.
Well, the story goes that a teacher once gave this exact problem to his class, probably just to keep them occupied for a bit. But one kid, a young Carl Friedrich Gauss, shot his hand up with the correct answer almost instantly. So the real question is, how on earth did he do that?
To get how Gauss pulled this off, we have to see the world through his eyes. He didn't just see a long, boring list of numbers. He saw a hidden pattern. See, this list has a very specific, predictable structure to it.
And that special pattern, it has a name, of course. It's called an arithmetic sequence. It's really just a fancy way of saying it's a list of numbers where the jump from one number to the next is always the same. And that fixed jump is what we call the common difference.
Take a look at this, for example. To get from 5 to 9, you add 4. To get from 9 to 13, you add 4 again. And so on. The common difference here is always a plus 4. It's totally predictable. And that big problem Gauss was solving, all the numbers from 1 to 100, that's just a super simple arithmetic sequence with a common difference of plus 1.
Okay, so spotting the pattern is step one. But the real power comes when you turn that pattern into a tool, a formula that lets us find any number in that sequence without having to write out the whole thing.
And here it is, the formula. Now, I know what you're thinking. It looks a little scary, right? But stick with me, it's actually super simple. AN is just the number you're trying to find. A1 is the very first number in the list. N is its place in line, and D is that common difference we were just talking about.
All right, let's take this for a spin. Here's a little puzzle for us. Let's say we have an arithmetic sequence that starts with the number 2. We don't know the common difference, but we do know that the fifth number in the sequence is 14. So the mission is to figure out the 12th term.
Now, what's so cool about this formula is that it's not a one-way street. We can actually use it to work backwards. We need to find D, the common difference. So we just plug in what we already know. The fifth term is 14, and the first term is 2. A little bit of quick algebra, and voila, the common difference has to be 3.
See? Once we figured out that key piece of the puzzle, that D is 3, the rest is a piece of cake. We just plug our starting number, 2, and our shiny new common difference, 3, back into the formula to find that 12th term. A quick calculation, and there we have it. The 12th term is 35.
Okay, so we've got the basics down. We understand the pattern. Now, let's get back to the main event. How in the world did Gauss add up all those numbers from 1 to 100 so ridiculously fast? Well, he used a trick that was just brilliant.
This is where the genius comes in. It's so simple, it's beautiful. He basically imagined the list of numbers 1 to 100. Then, he pictured another list right underneath it, but written completely backward, from 100 all the way down to 1. The magic happens when you add these two lists together.
When you start adding them up column by column, something amazing happens. Check it out. 1 plus 100, that's 101. 2 plus 99, also 101. 3 plus 98, you guessed it, 101. Every single pair adds up to the exact same number. It's perfect symmetry.
So the next logical question is, how many of these perfect pairs do we actually have? Well, we started with 100 numbers in our list, right? So if we pair them all up like this, we get exactly 50 pairs.
And now for the big finish. We've got 50 pairs. Each and every pair is worth 101. So the total sum is just 50 multiplied by 101, which gives us 5,050. Boom. That's it. Simple, elegant, and insanely fast. And that's how Gauss got the answer in seconds.
But here's the really cool part. What Gauss did wasn't just some one-hit wonder party trick. It's actually the foundation for a universal tool that works on any arithmetic series, and we can capture it in a simple formula.
This right here is the official formula. And if you look closely, you can actually see Gauss's clever trick hiding right inside it.
That A1 plus AN part, that's just his pairing method, adding the very first and very last numbers, our 101, and the n divided by 2, that's just the number of pairs, our 50. This formula just puts his brilliant idea into a neat little package we can use anytime.
So let's just prove it to ourselves one last time using this formal tool. For our original problem, we had 100 terms in our list, so n is 100. The first term, A1, is obviously 1, and the last term, AN, is 100.
Okay, now we just plug and play. The sum is 100 divided by 2, all multiplied by 1 plus 100. That gives us 50 times 101, which, to no one's surprise, is 50/50. It's the exact same answer, just captured in a powerful formula we can now use for any similar problem.
Okay, so at this point you might be thinking, that's a pretty cool math trick, but so what? Why should I care? Well, it turns out these kinds of predictable, step-by-step patterns pop up all over the place in the real world, in situations you probably deal with all the time.
I mean, think about it. A salary that increases by the same fixed amount every year, that's an arithmetic sequence. You can use this formula to calculate your total earnings over 10 years. Or what about a reading challenge where you commit to reading just 2 more pages each day? Same idea. Even something like a penalty for a contractor that goes up by $50 for every single day a project is late? Yep, that's an arithmetic series.
So here's the big idea, the main takeaway from all of this. What looks like a really messy, complicated calculation on the surface can often become incredibly simple once you find the pattern hiding inside it. This is about more than just adding numbers. It's a whole new way of looking at problems. And that leaves us with one final thought. Our world is just filled with these hidden, predictable patterns. In our finances, in nature, in our daily habits. So the real question isn't just about the math. It's about what you're going to see now that you know how to look. What powerful shortcuts and insights are you going to find in your own world? Thanks for tuning in.